Electric intensity at a point in electric field is defined as a force experienced by a unit positive charge placed at a given point.
But a force experienced by unit positive charge it is. Unit positive charge placed at a given point.
Sir, I have by mistakenly written change.
Okay, make it charge.
Thank you, sir.
Yes, unit positive charge placed at a given point. Fine. Now, unit positive charge, it is taken for, what we say convenience. Because if you take value 1, then the calculation will become very easy. But the true definition yes, the true definition of electric intensity, electric field, it is defined as, so you can just write it as, note. Let me take it one more. Fine, but you can write the definition, everybody. Electric field you can write it as node, then you can write the definition.
Yes, sir.
Yeah, electric field is defined as force experienced by a test charge. Force experienced by a test charge.
Sir,
Yeah.
will you please say again?
Yes, yes. Electric field at a point is defined as force experienced by a test charge in the presence of given charge. In the presence of a given charge. At the given distance from it. At given distance from it. Now the question comes, what is test charge, right? So write down. Test charge is a positive charge. Test charge is a positive charge. Positive charge. So small in magnitude. So small in magnitude. That it does not affect the surrounding of the given charge. It does not affect the surrounding of given charge.
So test charge is a positive charge.
Test charge is a positive charge so small in magnitude, that it does not affect it does not affect it does not affect does not affect the surrounding of given charge. Surrounding of given charge. It's written, Vacha?
Yes, sir.
Yes, sir.
Okay. So see, electric field, it's denoted by F bar upon Q, right? It's not visible, right?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. So E bar, it all dried up, I think. It takes some time. So right. So is it visible little bit?
Yes,
No?
sir. Yes, sir.
Okay, so it's C. You got a formula that is F bar, E bar is equal to F bar upon Q0, right?
Yes, sir.
So if I take this Q to be very small, so we use one, mathematical operation that is called limit. If I take limit Q tends to 0, so it means the value of Q will become very, very small, right? You have studied limit, Vacha, limit.
No, sir.
Okay. Just a second. So see what I have written here, it is E bar is equal to F bar upon Q, right? Now, what we are supposed to do here, test charge means it should be very small. So we use an expression that is But just see, if the charge is very small, so you will put one condition, key limit q tends to 0. So when I write q tends to 0, so obviously the charge becomes very small, right?
Yes, sir.
Yes,
Q
sir.
is not exactly 0, it is tending to 0, right?
Yes.
Yes.
So in that case, the general expression, we write it as E is equal to F upon Q, right?
Yes.
So if I write E is equal to limit Q tends to 0, F upon Q. So when I write Q tends to 0 means Q is very, very close to 0, but never equal to 0. If I say it is equal to 0, there is no charge, right?
Yes, sir.
So we get an expression that is limit Q tends to 0 can be replaced by like this, it can be written as F upon Q0. So when Q tending to 0, obviously instead of Q, we can write Q0, where Q is going to be, obviously it is going to be a test charge. Is it okay?
Yes, sir.
Clear up to this much, everybody?
Yes, sir.
Yes, sir.
But you can write it down. See, in exam, you will not write this definition. This is only for, understanding. Actually, you are supposed to keep very, very small charge so that when you place it, it should not affect the system. Yeah, it should not affect the electric field which is produced by the given charge, right? Is it okay?
Yes, sir.
So you can write it down. You can write E is equal to F upon Q. Then E is equal to limit Q tends to 0, F upon Q. Then E is equal to F upon Q0, where Q0 will be a test charge. So you know that test charge is a very small positive charge and it will not affect the surrounding of the given charge, right? Is it
Yes,
okay?
sir.
Yes, sir.
Fine. So now we will move towards the next derivation, that is electric intensity. Yeah, electric field intensity at a point due to a point charge. Means now you know only the general equation. Why this is not coming? Okay, anyway, so this is electric intensity at a point due to,
It is not visible.
yeah, it's not visible. So I think one marker, it is dried up, I think. So it is not taking anything. Let me try. Okay, fine. So you will check now. So electric intensity, is it okay now? At a point due to a point charge. Is it okay, bacha? Just check.
Yes, sir.
So I've written electric intensity at a point due to a point charge. Right?
Yes, sir.
Okay, bacha. So consider a point charge right? So we'll take that charge to be Q, placed at point O. O. Of course, in free space. Free space. Right?
Yes, sir.
Huh. So it means you can assume there is a point here, that is O, where you have placed charge plus Q. Right? So you can take this charge to be plus Q. Now at some distance, obviously it is in free space. So you will consider one more point, let it be A. Right? So at point O, you got charge plus Q. And at point A, you need to find electric intensity, and it is in, inside the electric field of the given charge. Right? So let P, sorry, not P, it is A. Let A be any point. Let A be any point at a distance let A be any point at a distance you can take the distance to be from here to here, it's going to be R, right? So R from point O, R from point O, and we need to find electric intensity at point A. So tell me, bacha, what we will do? Bacha, tell me what we will do. Is it audible?
Yes, sir, you're audible.
So tell me what we have to do to find electric intensity. At point A.
We have to use that formula.
Which formula? Bacha? First you have to do something.
That limitations all I was thinking, sir.
No. You need to place a unit positive charge, right? Because electric intensity is the force experienced by unit positive charge, right? So to find
Yes.
electric intensity at point O, you will place a unit positive charge. Let it be Q0. Right?
Yes, sir.
So a unit positive charge, that is Q0, it's placed here. Q0. Now, don't you think, bacha, Q0 will experience a force?
Yes, sir, it will.
It will. So this is positive and this is positive. So where will be the force? Will it be attraction or repulsion?
It will be repulsion.
Exactly, it is going to be repulsion. So can you write an expression for force here? If the distance is R according to Coulomb's law, what are you going to have now? But somebody's mic is on and it is creating a lot of disturbance. I think Kajal.
Yes, sir.
Bacha, Kajal, put your mic off, bacha. So anyway, you got Q0 here. That is, you placed a charge. Bacha, Kajal, are you there? Fine. Bacha, see, there is a charge placed at point O, and inside the electric field, you have selected one point. Let it be A, and at point A, you will place a unit positive charge that is denoted by Q0. I think all markers are gone. Okay, so it's Q0. Fine. So now obviously this Q0, because of this Q, it will experience a force. And obviously force, it is going to be in this direction. Right? So that will be the direction of force. Right? Right, Bacha? Yes, to find electric intensity, at point A, place a unit positive charge at point A. Right, so you place the charge. Now obviously this will repel, so we can use Coulomb's law now. So according to Coulomb's law, the expression for force acting on Q0 due to plus Q, the force acting on Q0 due to plus Q is given by. So tell me, Bacha, so you have got two force. One is Q0, another is Q. What will be the expression for force now if it is in free space? But the entire system is in free space. So tell me, 1/4 pi epsilon 0 you need to use, right? Tell me quickly, tell me, what will be the expression for force?
F is equal to?
F is equal to?
Like Q plus and Q0 like that, sir.
But see, Coulomb's law equation, you know, right? Two forces between them, what will be the force? It is in free space means you will be writing 1/4 pi epsilon 0.
Yes, sir.
So it's Q1, Q2, you instead of that you will write plus Q and Q0, right? So it will become Q0.
And R?
Square, right?
Yes, sir.
So now what we will do, see, first we will use the direction, means you will represent force in terms of vector. So I can use a vector here, and the direction of force is from O to A. Yeah, it is from Q to Q0. So you can write it as, unit vector is represented by r cap. You know that, right? Right?
Punishment is all. What do you do?
But everybody put your video on. Everybody put your videos on. Everybody. Sahil, Tanvi. Make it fast. Everybody, bacha. Durvesh, Bhavesh, Prathamesh, Roshni, Kajal, Salman. Make it fast. Make it fast. Danish. Roshni, Kajal, Prathamesh. Because I'm telling you again, keep the mobile video on. Otherwise, I'm going to remove right now. Harsh, Roshni. Taufik, Roshni, I'm going to remove right now. Now, then afterwards, obviously, I will not take you in. Then who is that? Shamyak. Fine. So anyway, you got expression for force, that is 1 upon 4 pi epsilon 0. It's Q naught upon R square. But up to this much, is it clear?
Yes, sir.
Yes, sir.
Yes, sir.
See, now, bacha, we are interested in E. We need electric intensity. So this Q0, you will take it on that side. So if I do that, Q0, if it is taken on that side, then you will have F upon Q0 will be equal to 1 upon 4 pi epsilon 0. You will get Q upon R square, right? Bacha, clear up to this much?
Yes, sir.
Now, F upon Q0, don't you think it is electric intensity, bacha? So you can write F is equal to 1 upon 4 pi epsilon 0. This is Q upon R square. So this will be the formula for electric intensity at point A. Is it okay? So simple it is F is equal to, that is 1 upon 4 pi epsilon 0 Q upon R square. Is it okay?
Yes, sir.
Yes, sir.
Yes, sir.
Fine. But you complete this, hopefully, the marker will get better. Complete this. But if anything is clear, you can ask me. Any word, yeah, this one, you can ask me. Salman, it is done. Salman, it is done. You're finished? Okay. So everybody finished?
Yes, sir.
Yes, sir. Yes, sir.
So one
Yes,
minute.
sir.
Okay.
So done.
Fine. So finally, we have got an expression that is E is equal to 1 upon 4 pi epsilon 0. That is going to be, Q upon R square. So if I compare that equation, right? Yeah, if I deal with that equation, then obviously I can, make out many notes from here. First one, if I take this equation as reference, see, you got E is equal to, it's 1 upon 4 pi epsilon 0. It's Q upon R square. So obviously for a given charge, R will be a variable. If charge is constant, R is variable. So I can take out, I'll take this to be note number 1. So I can write E is equal to, so it's going to be Q upon 4 pi epsilon 0. You know that it is going to be a constant, left with 1 by R square. 1 by R square, right? But is it visible? No, right?
No, sir.
No,
No,
sir.
sir.
Oh, so
But let me write this side. If it is not visible, then I need to shift the, change, reverse the board. I can write it in chalk there. Okay. Let's be there. Give me 1 minute. So I will reverse the board. But is it visible little bit? Half of the board?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. Okay, fine. So we'll check. Is it visible? But just check.
Yes, sir, it is visible.
Yes, sir, it's visible.
Okay, so it's you have got Q upon R square, right? E is equal to 1 upon 4 pi epsilon 0 Q upon R square. But we will do one thing. So we'll stop the lecture because I don't think this is also effective. Okay. So we'll continue next time. Is it okay?
Yes.
Okay, sir.
Fine, because I don't think this is also it will work. I think I don't know how the marker went wrong. It's okay, fine. So we'll stop now. So we'll continue next time. The same topic, I will take it again. No issues. Is it okay?
Yes, sir.
Fine. So
Sir.
we'll
Yes.
Yes.
Ashwini madam,
Yes.